Good morning. We are going to continue notes on 2.3 for the second day on this topic, which we're going to look at a handful of special trig limits. Damani students, you will also want to look at the 2.4 video because that's part of the assignment on the same day. So there's a couple limits that we actually want you guys to memorize. And as we go through different strategies in calculus, we are going to come to some analytical methods for evaluating these, but we're not there yet. We have some skills that we haven't learned yet in order to do that. But these are some surprising limits. First of all, if I take a look at the first one, if I try to use substitution, which feels like it could work because each one of these functions right here are continuous and well behaved, and so I have just a composition of functions here. But if I use substitution, the sine of 0 is 0. Let's see if I can fix this pen here. Here we go. So the sine of 0 over 0 is 0 over 0, which we learned at the last video. This does not mean that the limit's undefined. This is an indeterminate form. What that means, again, is that we do not have enough information to make a conclusion with this strategy. So I'm not going to be able to use substitution as my method. So my next strategy that I want to use is I'm going to actually use graphing, which this would be maybe a challenge to graph by hand. But if we graph this by using some technology, it's not so bad. It's going to take a minute for my technology to open up here. So I'm going to go ahead and look at the second limit for a minute, and then we'll come back to that technology piece, and we'll graph these in a moment. Okay, so if I take a look at this one again, I'm going to start with maybe some substitution. So it looks like I'm missing a variable here. Let me just add in that x. So if I substitute into 0, I have 1 minus the cosine of 0 over 0. Well, the cosine of 0 is 1, so this would be 1 minus 1 over 0, or 0 over 0, which is, yet again, another indeterminate form, which simply means my strategy that I used did not provide enough information for me to be able to actually successfully come to a conclusion. Okay, so I'm going to start with the sine of x over x. I'm going to graph this and see what's happening as we approach x from both the left and the right, and see if I can make a conclusion that way. So I'm going to add in a graph. Now, your calculator probably is already preset to be in radians, but if you want, you can check. I hit menu and then settings. And I like this to say fixed 5. If yours is on float, you might want to consider changing it. Fixed 5 always gives us 5 decimal places for any answers that don't end up being a whole number answer. And the reason I like that is because of the fact that that would allow, I'm not sure what's happening here, it's mad at me, but that would allow us to have everything be at least 3 decimal places, which is what we want for our calculus exam. Now this geometry angle doesn't actually technically matter because we are not actually going to be using that skill, but really we're going to use radians for everything. So if I'm going to hit my home screen really fast and check some other settings. I'm going to arrow over and choose option 5. For some better settings, I'm going to hit document settings, and I just want to make sure that what I really want, the 2 things, fixed 5 and radians. Those are really important. These other things probably are already set up correctly, but you can take a quick look. Okay, I'm going to go ahead and go back to a graphing menu. So I'm going to just go ahead and arrow over to the left side, and you could either arrow down or you could hit this button right here, which is just a little toggle. Right now I'm on a calculator. I want the graphing, so you can toggle that back and forth. So the first function I wanted to graph is the sine of x over x. Although you do have a keyboard available to you, you should never type trig functions ever. Your calculator is not going to actually recognize them if you type SIN. It will not recognize it. Instead, you need to use the trig button, which is to the left of the 7. And I'm going to do the sine of x, and then I'll get outside that parenthesis for the argument, and I want to divide this by x. Make sure you use this variable button x down here, and then hit enter. Now if I look at this graph, and I'm looking to see what height am I approaching for my function as I approach x along as I approach x equals 0 from the left side and the right side, I'm approaching a height of 1. And so that actually verifies this limit right here, which said, hey, if you are approaching 0 along the x-axis for this function, you approach a height of 1. So the graph, which would be a little challenging to graph by hand, did help us see that as we approach 0, let's see, what did that look like again? Kind of a little wave. But these waves are like a little bit shorter here, like they're just not super big. Okay, but I'm approaching a height of 1. Now this is one at this point that you should memorize because you do not have the background in order to analyze this analytically. So for now, this is a graph or a limit that you will want to memorize. Now let's take a look at this one graphically. We suspect it should approach a height of 0, and the function I'm going to do is 1 minus cosine of x over x. I'm just going to get back to my graph. A fast way to get to all of your entry points for entering in a function is you hit, I think it's tab. Yep. Now what I could do is I could call this f of 2 and enter in a new one and keep the old function there as well. But if I don't like that idea, I don't want that a graph that's got more than one graph, I can go ahead and just arrow up, and then I can delete that graph. And so because this particular one is going to have a binomial in the numerator, I'm going to put parentheses around that numerator, 1 minus cosine, use that trig button, of x. And then I want to get outside the argument and outside the numerator, and I'm going to divide that by x. And I can see on this one that if I move along the x-axis as I approach 0 from both the left and right side, I'm going to have a height of 0, which does help us see why this limit here is equal to 0. So we verified that graphically, even though these would be challenging to graph on our own, but we need to memorize these. Okay, so here are some examples. I'm not sure why my variable is not showing up here, but there is supposed to be an x there for that argument. So if I take a look at this first one, there are some strategies with limits that are a little bit intuitive that you may not be aware of that you can do. Right here, this portion of this expression matches this special trig limit here that I am supposed to memorize as equaling 0. And I'm multiplying that by 3. Well, the way you could think of this is this constant multiplier could actually just be moved as a coefficient in the front of your limit. So you could think of this as 3 times the limit as x approaches 0 of our same expression that we've been working with. And now we have the special trig limit. This is 3 times 0 according to our special trig limit, which makes this, I guess, not 3, which makes this equal to 0. So if you have a constant multiplier, you can pull that in front of the limit. Now, just because you have a trig function in your expression does not mean that you actually have one of the special trig limits over here. So you might see a trig function, but don't be fooled, that actually doesn't mean that it's a special trig limit. So I actually don't recognize a special trig limit here. We have sine of x over x as an expression that should be a trigger, but not with this tangent of x. So I'm going to try my first strategy, which is substitution. The sine of 0 over the tangent of 0 is 0 over 0, which is an indeterminate form, which means we cannot make a conclusion by just simply using substitution. So I need to try a new strategy. So what I'm going to do is I'm going to actually try to rewrite this in a different form by rewriting what tangent is. Keep in mind that tangent is really sine over cosine. And when you are dividing by a fraction, that's the same thing as multiplying by the reciprocal of that fraction. So really, this is x times the cosine of x divided by the sine of x. And I want to take the limit of that. But I can simplify out this expression to an equivalent expression that's the limit as x approaches 0 of the cosine of x. And now I'm going to go ahead and use substitution. Now once you use substitution, you don't have to write this limit portion anymore. But until you've actually substituted in that value, you must write that expression every single time. You might also notice I'm not using equal signs here. I'm using arrows. There's a reason for that. I'm going to explain it a little bit more when we talk about something called L'Hopital's rule. But for now, I just would appreciate if you are using limits to use the arrows. All right, so I'm now going to go ahead and use substitution. And so I'm really just evaluating the cosine of 0, which is 1. And remember, this was not one of our special trig limits. All right, so I had to use a different strategy. All right, for number 3, you can pause. This one is kind of related to number 1 a little bit, and give it a shot. And then when you're ready, you can restart the video. So what I'm noticing as I look at this problem is that this is very, very similar to the first special limit that we were supposed to memorize, the sine of x over x. But this is sine of x over 3x. So I have this extra constant multiplier right here that's on the denominator. We could think of this as a 1/3, if you'd like. So really, I'm going to rewrite this as 1/3. Let me change the font size here. I'm going to think of this as 1/3 times the limit as x approaches 0 of the sine of x over x, which we had found earlier approaches a height of 1 from both the left and right side. So this is really 1/3 times 1. I never actually used substitution on this one because I recognized it as a special limit. And my answer is 1/3. For number 4, let's see, actually I think I wrote this wrong. This should be the sine of 7x. Oh no, it wasn't. What was it? Let me look at your packet. I think it might have a different number there. Oh, 2. You guys have the sine of 2x over 7x, and I'm not sure why, but it just didn't show up here. Okay, so if this 2x and this 7x actually were the exact same constant here, like if it were 2x and 2x, then actually it would still apply to this limit. Basically, when we're looking at this special trig limit, whatever the argument is must also be the denominator. So if they were both 2x over 2x, I wouldn't have to do any extra work with this. It would just equal 1. But for this particular one, I have a 2x on the numerator for the argument, but the denominator is not also a 2x. So I can do this a couple different ways, but what I'd like to do is to try to see if I can use some maybe algebraic manipulation in order to make a 2x right here instead of the 7x. Now I can't change the argument, so my goal is to try to rewrite that 7x. Well, we kind of saw in the previous example that I could think of that 7x on the denominator. I could pull out like a 1/7, so I could think of it like this. 1/7 times the limit as x approaches 0 of the sine of 2x over just x. That's closer, but again, what I would like is whatever the argument is, I need the same expression on the denominator. So what I really, really want is I want there to be a 2 right here. I just can't randomly multiply by a 2 on the denominator unless I also multiply by a 2 on the numerator. Because that 2 on the numerator and this 2 on the denominator are being multiplied, they would actually reduce out to 1, and I haven't really changed the value of the problem, just the form in which it's written. And now I have an expression that matches the special trig limit. So now I can do 2/7 times this special trig limit, you might remember, approaches a height of 1. And so this would be 2/7 times 1, which is 2/7. We are going to have another lesson for this particular day, which is 2.4. And so you can go ahead and start that video after this one.